So this short video is on how to figure out the type of reaction. We have these 5 types: synthesis, decomposition, combustion, single replacement, and double replacement. So first of all, for synthesis, what you're going to look for is one product. Okay, if you only have one product, you'll recognize that this is a synthesis reaction because we have pieces that come together in order to make one product. So look at this list of reactions here. Do you see any with one product, one substance being formed? So if you look at number 1, we see one product. Heat does not count as a product. Okay, heat is a form of energy. By product, I mean a chemical substance. So number 1 is a synthesis because we see one product. Are there other reactions here that only have one product? So if I scan through here, I see number 7. Okay, so number 7 has one product here. So again, this is a synthesis reaction. So synthesis reactions have one product, and that's how you recognize them. Next type is decomposition. For decomposition, we are going to look for one reactant only, because this is one reactant and it breaks up into pieces. So looking through here, find one with only one reactant. That would be number 9. So number 9 has one reactant, okay? One reactant. So this is a decomposition. Okay, so number 9, let me put the numbers of so number 1 and number 7 are synthesis. Number 9 is a decomposition because it has one reactant. The next type that we'll look for is a combustion. So for a combustion, to recognize a combustion, we're going to see CO2 and H2O as products. Okay, so if we see CO2 and H2O as products, that's going to be a combustion reaction. So look through these, find reactions that have CO2 and H2O as products, and I see one right here. Number 5 has CO2 and H2O as products, so this is a combustion. And then if I scroll down, this challenge problem also has CO2 and H2O as products, so this is a combustion. All right, so we now know how to recognize combustion reactions. So the next type is called single replacement. So to have a single replacement, what we need is a single element, okay, replacing another element. And this element would be in a compound. So you must see, okay, you're going to have to see single elements as a reactant and a product. All right, so if we look through here, we've got to see these single elements, okay, that's why it's called single replacement, on the left and the right. So if we look at number 2, here's a element, F2, fluorine, on the left as a reactant, and it's kicking out the chlorine, and we see chlorine as a single element on the right. So this is a single replacement. Let's find another reaction that has a single element on the left and the right. Do we see any others? Here we go. Number 8. We see a single element, sodium, and it kicks out the hydrogen, a single element on the right. Again, this is single replacement. So for single replacement, we have to see those single elements on the left and on the right. Finally, the last type to recognize is a double replacement. So double replacement is when two ions replace each other. So if we look here, we can see in number 3, if I squared the lead, the Pb in purple, and let me use a different color, green, for the H, we can see that these are switching places, okay? The Pb is taking the place of the hydrogen, and the hydrogen is taking the place of the Pb, right? They're replacing each other. Okay, so we have a double replacement going on. So this would be double replacement. I'll abbreviate it DR. Okay, sometimes I abbreviate these DR and SR. And then if you look at number 4, again here, you have Fe, okay, over here, and Fe on the right over here. If we look at where the Na is going, we can see that the Na is replacing the Fe, and then the Fe is replacing the Na, and they're switching places. So that's a double replacement as well. Let me put it here. And if you look through, I'm sure you'll see another double replacement. Okay, so we have a double replacement in number 3 and number 4. Our single replacements are number 2 and number 8. And so I hope that gives you a quick overview of how to identify the type of reaction. So for synthesis, in summary, for synthesis, look for one product. For decomposition, look for one reactant. For combustion, look to see if you have CO2 and H2O as the products. For single replacement, look to see that you have a single element as a reactant and as a product. And for double replacement, you'll see the double replacement of two ions that are taking the place of each other.